going back, is we've actually created the main function first, which creates the sniffer thread and the injector thread using the pthread underscore create API. Now the point is the main thread has to know when the sniffer and injector threads have exited. To do that, it actually uses the pthread underscore join API, which blocks until both these threads exit. You can visit this link for a more comprehensive tutorial on multithreading. I might also take multithreading up as a separate section in this video tutorial series. Now the next fundamental logic which we require is of IPC, or inter-process communication. In the video series for this section, I'll just be concentrating on message queues. Message queues are nothing but linked lists of messages maintained by the kernel. The way it works is that a process can create a message queue and send messages to it, basically read and write messages, and any other process could once again read and write to the same message queue provided it has requisite permissions. Message queues typically allow for asynchronous form of communication. So one process or one thread could write a message to the message queue and then just return without bothering if somebody has read that message from that queue. At the very same time, another thread could just read messages from that queue without really waiting for somebody to write into the queue all the time. For a more comprehensive tutorial, you can visit the link below. Some of the message queue basics which you will require. The first is the MSG get API, which is used to create the message queue. We'll be using a function called ftoke to create the key, which is very unique for the message queue in question. Then we will use the message send API to send a message into the message queue. Now these messages should be of a particular format. The format is that the very first 4 bytes should be of type integer, long integer of 4 bytes. This is the only mandatory thing. After this, the message could consist of any amount of data which the user desires to send across through the queue. The last function is message receive, which is used to receive these messages which were posted onto the queue. So just using these 3 functions, we can create a message queue library, and that is what we do. So moving on to the final slide, what tools are we going to make? A tool which actually articulates the architecture which we discussed in the previous slides, and this tool will be called a generic tool. And then we would modify this generic tool to create generic tool -1.c, which would just send messages across 2 threads, that is the sniffer thread and the injector thread. Finally, as a proof of concept, we would create a tool which would reply to all ARP requests which are made on the network. This ARP DOS tool is basically to illustrate the above architecture. What this tool will do is that it will sniff the network for ARP requests, all ARP requests, and whenever it sees an ARP request, it will send a blind reply to that ARP request by spoofing a MAC address. This will result in causing a denial of service attack or a DOS attack on the network. We'll see more about these tools in the programming exercise below. Okay, that's all. So let the games begin. Please download the code for each of these exercises and follow the videos accordingly.